हाँ.
Hi, good evening. If I'm audible, just drop a bit. Thank you. Thank you. Okay, so we'll start the session at 6:10. We'll wait for some people if they join. Okay, and we'll start at 6:10 then. Fine. Yeah. Till then, if anyone wants to say about uh, themselves and what they are, why they are joining this course, that is groundwater engineering, that will be helpful for me to think like in what pace should I go and what level should I explain, something like that. Anyone wants to say about themselves? No? So should I take name of some people? You can say them, or else it's, if not, that's fine. You can write in the chat box also. That is also enough. You guys can write in the chat box, and then we'll start at 16. Okay. Yeah. So any of you, if you guys want to tell about themselves and why they are joining this course, they can write in the chat box or they can switch on their camera and let us know. We'll start the session at 16 if someone is joining. Okay. Okay, yeah, there is one lecture in which we will talk about groundwater crisis as well. Yeah, so I hope that will help. Okay, anyone else wants to say about themselves or why they are joining this course? Okay, and also if you are a college student or something, you can let me know. I'll try to make it as easy as possible so that any high level students or graduate students can also understand, right? So in these sessions, what we are going to do is, I firstly request you guys to go through the lectures of the week that we are referring to. Okay, so that's because what we are going to do in these sessions are to go through some questions, answers, and to how to solve those questions. And also, I'll go through the whole lectures of the week, but I can't touch upon all the small aspects. But if you have any questions, any doubts, or anything like that, you can tell me anytime. And whenever I'm explaining, you can ask me anytime if you have any issues. Okay, so the main aim is to understand the concepts if you have anything left in the week lectures. Second, to solve some example questions. I won't be solving the assignment questions that you have. I will help you to go through the assignment questions, but not the same questions. So I have formulated some questions which we will be seeing and we will do along with this session. Okay, and if you have any doubts regarding the assignment questions or anything among the lectures in the week, you can ask me anytime. Okay, anything, any doubt anyone have? Anyone wants to know anything? If not, we'll jump to the session. Yeah, Mohammed Shafiullah, your audio is on. Do you want to say anything? If not, I'll switch off the audio. Okay, so if no one has any doubt, we'll start the session now. Okay, first I'll share the screen. Okay, so good afternoon, everyone. Sorry, good evening, everyone. Today we are going to discuss about the week one lectures of the course called Groundwater Engineering, taken by Professor Arun Kumar Saraf from IIT Roorkee. And I am Balram Shah. I am the PMRF TA for this course, that is Groundwater Engineering. I'm a PhD scholar at Interdisciplinary Center for Water Research at ISC Bangalore. So with this, we'll start the session. Okay, the picture here will come to this at some point of the lectures or the session. Fine. So in this course, firstly, before going to this, maybe I'll share it again so that give me 1 minute. So in this course called Groundwater Engineering, firstly we'll see that in the whole lecture, in the whole course, what all we are going to study, and then we'll move to the first lectures, whatever we have studied. Okay, yeah. So what all we have studied. So firstly, in this week, what all we have studied, we will be coming to the introduction of the groundwater engineering, and then we will understand what is the importance of groundwater. One minute, I'll close this. Yeah. What is the importance of groundwater, and then why groundwater is important, and then we'll move to the hydrological cycle. Okay, so the introduction will be in the week 1. Then in week 2, we will understand about the surface water and groundwater, and then we will, as we are studying the hydrological cycle, we'll go move to the water balance and its components and types of aquifers. So mostly surface versus groundwater, then water balance and its components, and then aquifers and what is aquifers, what are the types of aquifers, and so on. Okay, in week 3, we'll move on to the processes which are happening in the groundwater, such as infiltration. Okay, what is infiltration and all we will come to know today, but in detail how we can model the infiltration and what all we can get through those we will study. We'll study the infiltration, we'll study percolation, then the properties of the groundwater or the subsurface. So we'll study about porosity, we will study about permeability, we will study about surface runoff, and so on. Then in week 4, we are going to study the laws. Let's say the Darcy's law we'll study. Okay, and then limitation of Darcy's law, where the Darcy law can be applicable, and then what kind of flows are there. So in the surface flows also we would have studied that there are different kinds of flow. Let's say laminar flow, turbulent flow, and so on. Like that, in groundwater also we will study what type of flow can occur, and then how we can get how much flow or how much discharge will be there in those groundwater flow, and so on. Then in week 5, we'll see pumping tests. So we'll see how we can see the layers or the subsurface layers, and then how much water can is extracted or how much water is available, and so on. We'll see using pumping test techniques, and then we will do some data analysis and interpretation. Okay, in week 6 we'll move to well losses, what kind of losses one well can have. Okay, and then some properties again like specific capacity, specific yield, and then collector well, infiltration gallery, and so on. In week 7, we will study about groundwater management. So someone was talking about that they wants to know because there are groundwater crises in India. We have seen in the northern part like Punjab, Haryana, and so on. The stored water is getting depleted throughout the years. So there are groundwater crises in India. We'll also see how the groundwater or groundwater things are there in India in today's lecture. But we will also study about groundwater management and groundwater balance in the week 7. Then moving on, in week 8 we will then move on to groundwater modeling. So after we are done with like what are the concepts that are there in the groundwater, so groundwater flow, the properties that affects the groundwater flow, and what kind of losses are there, then how we can manage the groundwater. After we know all the data, then we will move to model it so that we can predict the groundwater flow or groundwater level, and so on. So we can use models and on. So we'll see that in the uh, 8th week. Okay, so we'll also study about groundwater modeling and then groundwater balance and so on. In week 9, we will talk about the initial conditions and boundary conditions. So while modeling, we need to understand the conditions, boundary conditions, and so on. So we can solve the differential equations. We'll see the differential equations in week 4 and week 5, and how to solve that we will see in the week 9 along with the initial condition and boundary conditions. Okay, so in that only we will, because a model need calibration, validation. So all those things we will see in week 9, and also future predictions and so on. Then in week 10, we'll move to artificial recharge technique. So after we are done with understanding the groundwater and all the processes through it, and how to model those processes so that we can predict how the groundwater levels will be, how the groundwater storage will be. Then what we can do, based on that, we can manage the groundwater. So how we are going to manage? Using some of the techniques. One of them is the artificial recharge and so on. So then we'll move to artificial recharge techniques, then how we can reclaim the wastewater that are there. Okay. And then we'll move to week 11, in which we'll talk about aquifer storage and recovery, and then also seawater intrusion near the coastlines and all. We'll see all those things. And finally, in week 12, we'll talk about groundwater basin management. So we'll also see what is a basin or catchment today. So groundwater basin management and how the surface water and groundwater can be conjunctively used to have a better management strategies. Okay, and then we'll also talk about some contamination source inventory and remediation schemes so that we can reduce the groundwater crisis over India, not only over India but along the whole world. Okay, okay. So this will be the total outline of the course. Okay, and so with this, we'll move to the questions or the concepts. Okay, so with this, we'll move to the concepts. So the firstly, to understand the groundwater, what is important? Okay, we have not reached this page yet. Ah, okay, so what is the first thing that should come to mind when we are studying the groundwater? Firstly, what is groundwater? But let's say we know some part of it. Let's say we know water. So firstly, we need to know what is water, why water is important, and why should we study groundwater, right? And why should we study groundwater? So we know what is water, right? So water we know we need every day, right? So we know that water is important for life and so on, and it exists in all the forms like liquid state in water, gaseous state, that is water vapor, and solid state, that is ice, right? So we are not going deep into that. Just we'll move to how much water is available to our planet, because mostly we know that water is mostly available in our planet. We have also seen that it is also available in other planets, but yeah. People are still joining. I'll just can't read all. Yeah. So now we know that how and why water is important, right? So now we'll move to how much water do we have and how much water do we have in groundwater, right? So firstly, where is Earth's water? So we have our planet called Earth, right? So in that we know that, let's say, firstly, yeah, how much water is available in the Earth surface as in the thin layer of the Earth. We know, right? You guys can put in chat box if it is there. Firstly, how much Earth's water is there? It is around 71% of Earth's surface, right? We know around 70% of Earth is water and remaining is the land on which we live, right? Now, in this 70% of Earth's water, 70% of the Earth's surface, that is water that we have available. Among that, most of the water, that is around 96 or 97% of this water is there in the oceans, and hence we can't use that, right? So firstly, what we are concerned, why we are concerned about water? Because we need that water for our life, right? We need for all the purposes like drinking, irrigation, agriculture, and then industry and so on, right? So which all water we can use, which is available in this 70% of Earth's surface, is the first question. among that 70% of water, around 97% is in, or 96.5% is in oceans. Remaining 0.9% is other saline water. So let's say some sea water and so on, and other saline structures which are there inside the landlog. So including that, the total amount of saline water is around 0.9%. Remaining is the 2.5%, and this 2.5% is the fresh water which we can use. But again, in this fresh water, what we have, if let's say you consider all the fresh water as 100%, or let's say one bucket of water, in that the whole fresh water is again divided into 68.7% of glaciers and ice caps. So most of the water is available in which form? Solid form, that is in ice caps or glaciers, and hence it cannot be used directly. We know that in some of the catchments like Ganga River and those mountainous catchments, in summer season or some other season, glacier will melt and we'll get the water, right? But we cannot directly get it. So we can use some of the glaciers and ice caps, but not fully, right? Then remaining 30.1%, that is a huge amount, is available as groundwater. Okay, that is groundwater flow. And then remaining 1.2% is available to us, let's say in rivers or other fresh waters like in ponds and on, whichever fresh waters are available, we consider that. And then total amount of water, of fresh water, that is 2.5% of the whole water that is available on earth. Of that 2.5%, 1.2% is the surface or other fresh water which are available to us. Now in this 1.2% again, around 69% are in ground ice and permafrost. So you might question, like we have seen here in the second figure, that we have groundwater which is 30.1%. Now again I am saying that in surface or other fresh water, 69% is around ground ice and permafrost. So whether this groundwater and that ground ice are same or not, it's not same. So in the first one which we are talking about, that is 30.1%, that is groundwater flow that is happening. But some of the, in some mountainous areas, let's say in India only, if you see Ladakh and some other areas, you will see water is stored in the form of uh, solid ice, in form of permafrost and ground ice. Okay, so those are around 69%. Then around 20.9% is in the form of lakes, 3.8% is soil moisture, swamps and marshes around 2.6%, rivers is around 0.49%. So we know India has a rich heritage of so many rivers. We have Ganga, Yamuna, or Yamuna is a territory. So Ganga, Indus, Brahmaputra, Krishna, Kaveri, Godavari, Narmada, Tapi, and so on. So we have a lot of rivers uh, just in India. So if you just consider the whole world, among that only 0.49% of this fresh water is in the rivers. Okay, and then living things has around 0.26%, and atmosphere. So we know, the atmosphere that we have, that also contains some amount of water vapor in it. So that water vapor is around 3.3%. Okay, so these are the total surface water and other fresh waters. Okay, any questions in this? So if you see groundwater total, so if you consider that, if someone is asking you how much groundwater is available to you of the total earth surface, so it is around 1.7%. How 1.7%? That is 70% of this 2.5% is that 1.7%, something like that. Okay, now if we see this in the form of our earth, then we see if the whole structure that you can see is our earth, then if you consider this as total water, that is 100%, then this one is the ocean water. You see, if you see visually, ocean water is almost equivalent to the total water, which we have seen before. That is around 96.5% is the ocean water. Remaining, if you add all this, that is frozen water, groundwater, a very small part, if you can see, is lakes and river water. So if you add all this up, you will get the total water. Okay. Any questions here? If move to the next. If you have any questions anytime, you can interrupt me anytime and you can ask. Okay. Okay. So just the what we have seen, we can also see in this form. So this one is total 100%, which so this is the 100% of the 70% Earth's water. 96% is oceans, then freshwater, other saline water, then again that freshwater is divided into glaciers and ice caps and so on. So the same figure that we have seen here is shown in this figure. Okay. Okay. And just to have estimate in numbers, because now we have only seen in percentage, if you want to see in numbers, okay, it's something is happening. Okay, I think here it will come. Okay, so here we are seeing one estimate of the global water distribution. So let's say if you consider the whole globe, then you see here water volume in cubic miles. You can see this obviously we mostly use kilometers or in meter cubes, right? So we'll see this column. You can also see other columns, but let's say if we are seeing this column, then water volume in cubic kilometer, that is if you can write in this form, then it is around this much. Okay. And then remaining, let's say groundwater is how much? It is around 23 million. In that, fresh water is around 30.1% and saline water is around 0.93%. Or, yeah, right? So this one is the saline water and this one is the fresh water which we are after. So just to have a number crunch, we are just seeing this. Okay, fine. So we'll move to the question then. So the first question that we will be seeing today, it might be very simple because this is the first lectures. Okay, so the first question is what percent of the global population depends solely on the groundwater resources for basic daily water needs? These are some information question. If any one of you can answer, you can put the option number in the chat box. Anyone? Out of the total global population, how much do you think that people rely on the groundwater resources for basic water needs? If you can switch on your audio and answer. Okay, one says 50%, that is C. Anyone else? 50%, okay. 43, okay. Anyone else? 43, fine. Anyone else? Okay, so we have got two answers, three, that is 43% and 50%. So here we are talking about basic daily water needs. Okay, 25%, fine. Okay, anyone else? Anyone for 75%? This relying on groundwater resources has been increasing or like alarmingly increasing in the recent decade. So if you see after industrialization, this has been increasing. Before we were uh, relying on mostly on the rivers or the surface water bodies, right? So yeah, just now if you see what percentage of global population uh, rely on the groundwater resources for basic daily water needs is around 50%. Okay, if you talk about 43%, you will see that is along only for drinking and all. If you consider everything, then it will be around 50%. So for this, the correct answer is 50%. Okay, okay, we'll move to the next question. The next question is, what do astronomers search for in exoplanets as a key ingredient for life? Your options are oxygen, liquid water, methane, and carbon dioxide. Anyone? Liquid water, okay. Just because we are studying water, it might be possible, but okay. CO2, okay. Because from there the evaluation started, okay. Mhm. Okay, fine. Where is my pen? Yeah. So here, if you say for the key ingredient of life, then the correct answer is liquid water only, because if you see life on Earth, the life on Earth started with fire and then water and then we moved on, right? So mostly people start for, or mostly the astronomers start for liquid water as the key ingredient of life. But it is also true that other components, that is methane and oxygen, these things also astronomers search for, but the key ingredients for life is the liquid water, that is they search for. Okay, so the correct answer is B, that is liquid water. Okay. Okay. The next question that we have is, which organization specializes in regional and transboundary level assessment of groundwater resources? Your options are Food and Agriculture Organization, or FAO, then IGRAC, that is International Groundwater Resources, and International Groundwater Resources Assessment Center, and then World Bank or UNESCO. Option B, that is IGRC. Okay. Anyone else? Three, four we have got. Okay. Option B. Okay. Okay. 1 minute. Okay. Anyone else? Fine. Yeah. So the correct answer for this, which the organization which specializes in regional and transboundary level assessment of groundwater resources, is the the full form. What I said was International Groundwater Resources Assessment Center. Okay, so yeah, along with that, there are other organizations also. For example, here we have seen UNESCO. One branch of UNESCO, or one sister of UNESCO, you can call, that is UNESCO IHP, that is Intergovernmental Hydrological Program is there. So UNESCO IHP also specializes in the groundwater assessment of the whole globe. So that also you can consider. But for this, on among the options, the correct answer is IGRC, that is International Groundwater Resources Assessment Center. Okay. Okay, fine. Next question that we have is, which of the following reservoirs contains the most water? Your options are atmosphere, biosphere, groundwater, lakes and rivers. Anyone? C, groundwater, D, lakes and rivers. Okay, lakes and rivers, groundwater, groundwater. Okay. Anyone else? If you have any questions, like if I'm correcting the correct answers or something, and if you have any doubt why that is so, and if you have doubt on other options, you can switch on the audio and tell me, or you can write in the chat box also. There is no issue. You should not leave with confusion here. Okay, so people have said about groundwater and lakes and rivers. So just now we have seen the plot, right? Biosphere, okay, okay. Groundwater, biosphere. I'm hoping people are not changing their answers. Okay, let me see. Okay, okay. Yeah, so we have seen in the plot, right, that here biosphere as in, can you, anyone tell me what is biosphere? Like what part we are talking about as biosphere? Anyone? Yes, kind of. So what is biosphere? Biosphere is like a global ecological system. So it's like in which all the life exists, right? So it can be like the seas or the upper area of land, okay, and then the whole ocean or the deep oceans and so on, and the lower part of the atmosphere, okay. Yeah. So for this here, what we are saying is in okay, here the it should be most fresh water was the question for me, okay. Yeah, so I was talking about the fresh water here. Obviously the answer here will be biosphere if we talk only about the water, if you include the saline water and so on, okay. But if we talk about the fresh water, the groundwater, as we see that in the total fresh water, the we have seen that 30% or 30.1% was the groundwater, right? Atmosphere. Okay, we'll go to that slide if you can check once. Here you see in the fresh water 30.1%, sorry, 30.1% is groundwater. Atmosphere in this surface water, wait, surface water is around 3%, right? So for this, we were talking about the water that we can use. So the correct answer for this will be groundwater. If we talk about only water, then it should be biosphere. Okay. Okay. So the next question is how much of the, okay, I'll close this so that you can see the whole thing once. Yeah. Sorry. So how much of the Earth's water is stored in the underground aquifers? Okay. The answer came first. Fine. So in underground aquifers, as in aquifers, if just to know that what is aquifer, it is a structure in which water will be flowing in the subsurface. We'll talk about aquifer in the later lectures. Most fresh water is in glaciers, so glacier will be a part of 1 minute. Also is in glacier, so glacier will be a part of biosphere. So in freshwater questions, answer should be biosphere only. Yeah, I mean, yes. Okay. So if you just talk about the fresh water, it is biosphere, okay. But here, uh, fine, okay, yeah, correct. Biosphere will be the answer, but this question I took from somewhere. I will check once. I mean, the question was different. It was only talking about the subsurface layer. We were not talking about atmosphere. But fine. For this question, answer will be biosphere only. Okay. Okay, fine. We'll again come back to the second question. That is how much of the Earth's water is stored in the underground aquifers, right? And aquifers, as I said, that it is a structure, or it's not a man-made structure, but it is a structure in which groundwater will be flowing or groundwater will be stored. Okay, we'll come to the definitions of aquifer in the later sessions. Fine. So let's understand that it is water which is available under the ground, kind of. Not the whole water, but still. And we have seen how much was the groundwater in total of the Earth's surface. We have talked about it, right? How much was it? If you have seen the total, I have told was around 1.7%, right? That is including both groundwater flow and groundwater, the stored groundwater. Okay, but here we are only talking about the stored water. Okay, so the stored water will be obviously in these four options. If you see the groundwater only is 1.7%, right? And this groundwater includes both groundwater flow as well as stored groundwater, right? So the stored groundwater in the underground aquifers will be option A, that is less than 1%. Okay. Any question here? Fine, we'll move to the next question. So this one will include both flow plus stored groundwater. Okay, fine. Okay, this question will come to later. Okay, so before that I have one slide, I guess. Yeah. So till this, do we have any question? Anything? If not, we'll move to the next understanding. Fine. So now, no, fine. Okay. Anyone else? you have any question anytime, you can interrupt me in between and ask. Okay, fine. Okay, so now we are not going to hydrological cycle. We'll come to that, but we know that water will flow inside below the surface, and that we'll be considering as the whole groundwater. In that we have different layers. Okay, so if we talk about the water that is flowing under the surface, that is not only groundwater. What all layers are there? If you divide into three parts, okay, so if let's say we are talking about the vertical distribution of water when is when it just crosses the surface of the earth, it divides into three components, that is Beddoes water, or we call it as unsaturated zone. Then we have the groundwater or phreatic water, we'll see, and the final one is the internal water. We'll see this how it is. Okay, so here you see, if let us consider that this is the ground surface. Okay, so when water is flowing vertically, first we have this one. If we talk about the bigger one, we call that as unsaturated zone or Beddoes zone. Here we are seeing that it is called as unsaturated zone or Beddoes zone. Now this unsaturated zone, why it is called unsaturated? Because the water is not present fully. That's why it is not fully saturated. And that's why we call it as unsaturated water. Saturation we know, right? If there is any presence of water there, we call that as saturation, right? So if the water is fully present into the volume, we'll call it as fully saturated medium. If there is only some part of water is there, we call it as unsaturated or semi-saturated medium, right? Okay, so in the unsaturated zone, first we have is the soil zone. So first, let's say whenever the precipitation happens, the water which will flow is in this zone, that is soil zone, right? So in the soil zone, whatever water will be there, we call that as soil water or soil moisture. Okay. Then if let's say more water is coming, then it will move to this layer which we call as intermediate water. Okay, and finally there will be a small capillary fringe. We know the capillary phenomenon, right? So let's say if you consider any small pipe or any small glass pipe also, if you see, if you dip it in water, you will see that the level won't be like fully horizontal. There will be a curve there, right? That curve is because of the surface tension of the pipe or in internal surface tension, and then the adsorption, sorry, the surface tension and both the what is that? Surface tension and the adsorption that is happening, right? So because of that, there will be a capillary fringe, which is because of the capillary action. Right? So this capillary action will be happening when the surface below the capillary fringe is fully saturated. Okay, so below this, whatever zone we are having, we call that as saturated zone. Okay, so in this saturated zone, we call this as zone of saturation also. You can call it as zone of saturation. So in this only groundwater will be available, and below that it can be like fully water is there. We call that as internal water. Okay, fine. So as I said, it is also called as zone of aeration. Okay. Now, if you now in this, the main focus of our course is on groundwater, right? So what is groundwater? Where does it occur? So groundwater occurs in the zone of saturation, right? In which all the interconnected voids are filled with water. As I said, in fully saturated medium, what will happen? The whole medium will be filled with water wherever voids are there, right? Filled with water, that is under hydrostatic pressure. Okay. Yeah, but just to note that here we are talking about in which all the interconnecting voids are filled, right? It is not always applicable, but most of the region in our world, we can see that wherever interconnected voids are there, mostly those are filled with water, and that's what we call as zone of saturation in which this groundwater is available. Okay. So, what is groundwater? If you just see by definition, the water which is present beneath the earth's surface in rock or let's say soil pore spaces and in the let's say fractures of the rock formation, those water we call as groundwater or subsurface water. Subsurface water because it is below the surface, right? You will see groundwater called as phreatic water also. It is also called as subsurface water and so on. Okay. Okay, fine. So here, one more thing we are seeing. Can you see this symbol here? So this symbol represents water table. And in this figure, it is shown that water table is a completely horizontal line. It's not applicable in the original cases or the real scenarios. In real scenarios, let's say wherever you are sitting or standing, if you go below that, it might be possible that the water table is little fluctuating. Yeah, a very flat water table is mostly available in plains. Let's say the delta part of Ganga River basin and so on. You'll get a flat water table, but not always. What is evapotranspiration? Please define, sir. Yeah, evapotranspiration will come when we will talk about hydrological cycle. Okay. Okay, so here, what are the components that we have seen here? Firstly, we are talking about the vertical distribution of water. Whenever the water is, let's say, left as precipitation, the water will go and will have a vertical flow, right? Now, from starting from the surface, what we have seen, the first layer that is there, what we call that as soil water, right? So soil water or soil moisture, which mostly in this Vedo zone, the let's say some trees or plants and so on, they suck it to have life and to make fruits or something like that. So after the soil moisture, we have intermediate water, which is again unsaturated. So all the voids are not filled. And then again unsaturated zone is there in which we call it as capillary fringe. That is because of the capillary action of water and the soil, right? So water will have a capillary action and because of which a thin layer will be there as capillary fringe. And this whole layer we call it as zone of aeration and zone of aeration or unsaturated zone. Now, after the unsaturated zone, the water will join the saturated zone in which most of the interconnected voids will be filled with water. And this we call as groundwater or phreatic water. Okay. Any questions till this? This evapotranspiration precipitation will come when we will talk about hydrological cycle. I want to explain all the components in detail there. Okay, any question here in the vertical distribution? It should be clear like all the layers. If you have any question, you can ask. Okay, anyone else? Okay, fine. Okay, so now we know the vertical distribution of water, right? So we should also know that what kind of waters are present or what kind of classification of groundwater. So this will come little later. First, we'll jump back to the questions again. Okay, what was the question that we were after? We were here, I guess. And this question anyway we have finished. So okay, this I have not talked, but okay, fine. So the next question is groundwater is also referred as your options are. Okay, option is only coming before. Okay, so your options are green water, blue water, gray water, and all of the above. Now that the answer is here, you can tell me why we call it as blue water, if anyone knows. Anyway, I'll explain. Just to, if you can just think a little, you will get the answer. It is a very like easy explanation why groundwater is called as blue water. Because of color. Okay. Anything else? One thing about color is you might have seen in the lecture that if you see a small droplet of water, you will see it is colorless. But let's say if you see a vast um, body of water, let's say ocean or something like that, you will see it as blue. Why? That is because of the reflection and absorption of water and the electromagnetic spectrum which we have studied. Okay, we are not going to into detail, but just here because in many of the cases you will see that groundwater is referred as blue water and so on. It reflects blue color. Okay, blue in color, nothing else with green and gray. Nothing else with green and gray meaning I didn't get it. Okay, along with this, then I'll have a question whether any water is called as green water or gray water. Anyone? Firstly, it reflects all the water. Just for our visible spectrum, we will be seeing only few colors, right? Just to note down that water will reflect all the color, just that whichever color is there in the visible spectrum, we can see that. Gray water is impure water. Yes, kinda. I'll come to that. Okay, fine. So we'll come to that only directly. Okay. So what kind of waters you will be seeing? Let's say if we divide, firstly, there will be some water on the surface, right? Surface water will be there, and then there will, sorry. Uh, there will be some flow. Let's say this is the water table, and this is a groundwater. So you will see as groundwater, right? And after the use of this surface water and groundwater, so let's say the surface water and groundwater are used. After this, what what will happen to those water? It will become water is a category of wastewater. Yeah, correctly. So after the use, it will become wastewater. So just if you see the small, because we have life on the surface, we have life also in the underground. But just to note that most of the Earth surface are green in color. The vegetation and all you will see in green, and that vegetation is because of the water they intake. Okay, so mostly the surface water will be called as green water. Next comes the pure water or the groundwater, because mostly the groundwater will be pure or pristine. Why? Because most of the contamination will be on the surface water, but nowadays, because of increased human intervention or human activities, anthropogenic activities, we are seeing that groundwater are also getting contaminated. But just because the pure water or pristine water, that is groundwater, is blue in color, which we can imagine, and that's why groundwater is called as blue water. Finally, gray water is the wastewater. So if we mix anything in the, let's say, colorless thing, it will become something like gray or black, then that water will be called as gray water. So for here, just to know that groundwater is also referred as blue water. Okay. Any question here? Am I clear with all the different colors of water? Okay, if there is no question, I'll move to the next question. Fine, there is no question, right? No questions. Okay, okay, thank you. Fine. Okay, so we'll move to the next question. Sorry. Yeah, so the next question is the boundary between the saturated zone and the unsaturated zone is also called the, do you guys need option for this? So just now we talked about vertical distribution, right? And the main, let's say if this is the ground surface, yeah, if just to note, wherever you see this kind of symbol, I'm calling that as ground surface. Okay, so from now onwards, if you see this I'm making this symbol, that is groundwater ground surface, And if you see me making this symbol, this means water table or groundwater table. Okay, so now we have talked about this layer. Just below that is called the unsaturated zone, right? Or the zone of aeration. And this zone we call that as saturated zone. Sorry, saturated zone, right? So the boundary between the saturated zone. So this one which you can see is the boundary between the saturated zone and unsaturated zone, right? Which we call as water table or groundwater table mostly, right? Okay, correct. Thank you, Safiola and Dhyani Jayesh. Okay, fine. So the correct answer is okay. Sorry, this is wrong. Maybe while writing I wrote it mistakenly. Option is A, water table. Okay, fine. These things, aquifer, aquiclude, porosity, these are also some terms in water and water resources, but we'll come to that later. Fine, you will come to know about this. Fine. Yeah, so where I was talking about the classification of groundwater, right? So now the groundwater can be classified into different forms based on what factors you are considering, right? So the firstly, based on, let's say, the origin and the source, I'll have one question here. Okay. The question which we have here is, which of the following refers to the water entrapped in the interstices of the sedimentary rocks at the time of its deposition? Here, interstices and voids are generally used interchangeably. Okay, so let's say if this is a soil layer and this is some soil particles or rock or whatever you can think of. So you will have voids here. So these things are voids, right? Or we call this as interstices. If you just consider a just regular thing or regular layers. Okay, so let's say I am just making hypothetically one scenario where rocks are kept something like this. So in this, if I change the color, fine. So you can see this part, right? This part, this part. These are the interstices or the voids. Okay. So this we call as interstices or the voids. Yeah. So the question was the water which is entrapped in these voids of sedimentary rocks at the time of its deposition. So whenever the water was the sedimentary rock was deposited, and after that the water was entrapped into the voids of those sedimentary rocks, those water what we call. So as I mentioned that the classification, I'll change the color again. If you classify the groundwater, it can be classified into four based on the origin and the source. Based on origin and source. Okay, so the first water that I have written in the options are the juvenile water. What is juvenile water? From the word only you can understand that which is A or C. Yeah, we'll come to that. I'll explain one all the classification and then you guys can answer. Okay. Yeah. So the first one is juvenile water. What is juvenile water? From the word juvenile only you can understand, which is very like yeah, okay, which is very like in the initial form or something like that, right? So, so the water which are derived from very interior of the earth, which is very pristine and pure, we call that as juvenile water or magmatic water, which comes from, let's say, which is under the magma, something like that. Next we have is the meteoric water. What is meteoric water? Meteoric water is in, yeah, so one word you will be seeing in many places is meteorological, right? What is meteorological? Meteorological is the word which comes from meteorology, right? Which is the study of atmosphere or the any elements that are present into that. So here what we have is meteoric water. Meteoric water means the water which are derived from atmospheric precipitation and in circulation. So whatever water which is there in the atmosphere, so we know that water will always in the flux, so it will be moving always. So the water which is derived from atmospheric precipitation, or let's say the water which is in the circulation, we call that as meteoric water. Okay. Third one here is connate water. What is connate water? Connate water are the water which are, let's say, mostly found in sedimentary rocks, for example, sandstone and so on. So this connate water is also called fossil water, and mostly these are water are saline, not always, as most of the time the connate water or the fossil water is saline and it is present in the voids of the sedimentary rocks. And D is the volcanic water. What is volcanic water? So let's say there is any volcanic activities or any volcanic source. So because of these activities, along with the magma after it might be possible that because of this heat and chemical activity, some water will be stored there. So these water which are derived from this heat or let's say chemical activity from these volcanic eruptions or volcanic activities, we call that water as volcanic water. Okay, yeah. So we'll come to the question now. Can you tell me what will be the answer for this question then, based on the explanation that I gave? C. Okay. Anyone else? Answers anyway we will get. I just want you guys to understand the concepts and the definitions, everything. Okay. If you have any question, you can ask me. Okay. You can get answers after the session also. Anyway, it will be recorded. Okay. One answer I got is C, that is connate water. Okay, anyone else? Fine. Yeah, so the correct answer is the connate water. Okay, so the correct answer is connate water. But do you guys understood all the classification of water? You can give me a thumbs up or you can write in the chat box. Yes, okay, fine. Fine. So we'll move to the next question. Okay, now that we know that how groundwater works or how where the groundwater is present, what is groundwater, what are the layers of the water that are present below the surface, and what kind of like what are the classification of groundwater based on origin and source. Now we need to understand why this groundwater is important. Firstly, we understood based on how much water is available, right? Based on the earth's surface, how much earth's water is there, and based on that earth's water, how much fresh water is there, and in that fresh water, how much groundwater we have, and in that groundwater, how much we have right now, right? So now let's move on to our country, that is India. Okay, before this, let me just explain a little. Give me just some number crunch. Okay, so we will talk about the water resources in Indian scenario. Okay. Also, if you guys want to read about this groundwater or something like that, let's say some books, if you guys want to refer, I'll there are some books. Let's say David Todd, David Todd and Mees. That is David K. Todd and L.W. Mees, I guess. Then Freeze and Cherry is there. So mostly the instruction that you will get in these books will be based on the foreign things because those are foreign authors, and you will also get some books, Indian books. Okay, I think Subramanya has one, K. Subramanya, Subramanyam or Subramanya, something like that. K. Subramanya is there, and one more book is there which you can see in the in PTL. There is some option there. It is mentioned, I guess. Okay. If you guys also want later, you let me know. I will tell you. Okay. H.M. Raghunath, correct. Raghunath's book is there, which will give you this Subramania and Raghunath will give you the perspective of how the groundwater is there in the uh, our Indian domain or Indian scenario. Okay, fine, fine, okay. Okay, so before going to the groundwater scenario of Indian water, what we need to know that how much water do we receive? Mostly, if you see the average precipitation that we receive in India is around 1100 to 1200 millimeter per year. And you will see, let's say if you see last 50, 20, 70, more than 70 years also, you will see the average has stayed near this only, around 1100 to 1200 millimeter per year. So around, if you see in the volume, around 4000 kilometer cube of water do we receive throughout the country. Okay, and then out of those 4000 kilometer cube of water which we receive annually, around 1720 kilometer cube of fresh water we use per person every year. Okay, so we know like how much, sorry, not kilometer cube but meter cube. Yeah, because kilometer cube in three people only it will be over. Yeah, so around 4000 kilometer cube of water we receive as form of precipitation every year, and out of which around 1720 meter cube of water we use as fresh water every year per person. So we know the population of India, and then you can calculate how much water do we use every time. Okay, so we know that population of India now we are making to the top of the world. So the population is around 18% of world's population, Indian population, world's population, right? And in this, and how much do we have water resources? Around 4% of the total world's water resources we have. Okay, so around 4% of the whole globe's water resources we have in India. Okay, okay, fine, fine. So anything else we have to tell? Yeah. So if you just see every year, and mostly the water that we receive is in monsoon season, you will have, again, the monsoon varies a little different in different space. So if you see, India is a big, very big country, right? So if you see the northeast part and the Kerala part, these places receives rainfall or precipitation earlier than that of the other parts of the country, right? So in time also we see that the rainfall receives is in different months, or it starts, the pre-monsoon starts before, whereas in some other parts of the country if you see, it will be uh, with this June, July, August, September, right? So mostly the monsoon, if you see, it is within this months, that is June, July, August, September. However, because of the climate change and anthropogenic activities, you will see that in some places there is a shift in the months. Maybe if in the beginning, or in let's say for 50 years back or 70 years back, you were seeing that precipitation was starting at June 1st, for example. Now it is starting in 15th of May or something like that. And in some places, you will see if it was starting at June 1, it is starting in June 15th or maybe later stages. So because of this climate change and anthropogenic activities, the precipitation and other factors of the hydrological cycle also have been impacted, just to note. Okay, so India, if you see, it harnesses around 761 kilometer cube of its water resources. So the water resources that we have, uh, out of that, it's around 20%. So out of that, around 20% we extract, or not extract, we use. Okay, because most of the water we will see is present in the glaciers in Himalayas and so on, right? So 20% of the water resources that we have in India, we use it, okay, for our purpose. Okay, so that is around 761 kilometer cube. And if you see vaguely, maybe in Rajasthan, sir, do we get the PPT, or we have to write it down by? No, no, this PPT you're talking about, right? The one which I am explaining, or the one which, this one, right? So this one I'll upload. Maybe within 2 days of all the sessions, I'll try to upload both the PPT and that session that we are having. Okay, yeah. So as I said, that 20% of the uh, India's water resources we use for our purpose. Now, in this, what are the main aspects where we use water? Can you guys tell me? What are the main fields or main, uh, if you major aspects, if you see, what are the major aspects in which we use water on a daily basis or in a bulk amount? If you guys can switch on the audio and answer, that is also fine with me. Bathing, cleaning, okay. I'm also using water. Irrigation, okay. Do we use water anywhere else? Okay, irrigation is a good part. Agriculture, domestic, electricity generation, okay. Irrigation. So the bathing, cleaning, and so on, and also which I did just now is the drinking. These things, whichever we domestically use, will come under domestic. Okay, so domestic as in means municipal water or drinking water applications we can use, and one of the important part is the industry part, right? Yes, Yagesh. So electricity generation mostly we do by hydropower, but in India most is by thermal power. Some part is around 20 to 70 to 20% is hydropower, I guess. So that comes under irrigation again. So the electricity generation again comes in uh, the hydropower plant, but it's not a waste because the water that is there that only will be used again and again. Fine. So for here, you will see around 688 kilometer cube of this 761 kilometer is used in irrigation. And then around 56 kilometer cube of water is used in the domestic purpose and industry uses around 17 kilometer cube. Okay. This is just estimate. Obviously, there will be ups and downs in these values, but this is the major part that we have. Okay. Fine. Till this it is clear, right? If it is clear, I'll move to the second, I mean next part. Yes, right? Okay. And if you see globally, so we saw that of our water resources, we used around 20% of the water resources that we have. And if you see globally, then globally, our country, as in India, uses around 25% of all groundwater that are extracted. So all the countries, not all the countries, but most of the countries extract groundwater for their need right and nowadays, right? So out of those extracted water, remember, not all the groundwater, but extracted water, India extracts around 25% of all the groundwater that are extracted globally. Fine? Fine. So we'll move to the question. What was the question? This is done. Fine. Okay, so the next question is most groundwater withdrawn in the India is used for, just now we have seen, right? BB, okay. Anyone else? Johnson, Dheeraj, Leena, answers? Do you have anything to say here? Most of the groundwater which are withdrawn in India is used for, I got two options, two answers, that is B, irrigation. Anyone else? Yagesh, B, Surendra, B. Okay, fine. Yeah, so just now we have seen, right? The irrigation is the highest amount, right? How much? What was the estimate? Around around how much volume of water do we use for irrigation? And again, that is an average. Okay, it might be possible that every year it is little increasing or decreasing. Yeah, it is around 688 kilometer cube. Okay, so Uh, just a curiosity question. What do you think? In which year, let's say, there is a drought year as in most of the part of India, we have received water or we have received water less than the average annual. Okay, so average annual precipitation, how much it was of India? Of India, the average aerial rainfall was around it was around 1100 to 1200 millimeter, right? Now let's say if some year is there in which less than this average, so let's say 800 of rainfall happened all over India. Okay, so that let's say we are considering that as drought year, whereas some year it might be possible that is more than average, that is let's say 1500 of water has happened. So what do you think, in which year the groundwater extraction will be more, and why? I mean, if you just don't want to type, you can switch on the audio and speak. There's no issue. 800 because the natural coming water is less. Yeah, because the average amount of water that we are receiving, we are having drought. So we are having less water on the surface. So if you see drought is also different classes are there: meteorological drought, hydrological drought, agricultural drought, socioeconomic drought, and so on. So this meteorological drought is the drought when we receive water or rainfall below average as in average annual rainfall. So in that year, first thing which will be affected is the surface water, and because of that the amount that are available on the surface are less, and hence we have to go deep into the groundwater and we have to extract, and hence the drought year we will extract more water for our purpose, let's say irrigation or industry or drinking and so on. Okay, fine. So the correct answer for this is irrigation. Okay. Next question what we have is, which of the following statements about the water table is false? So just now we have talked about water table, right? And next time I'll make this sure that these options does not come before. Okay. Yeah. So which of the following statements about the water table is false? First option is the water table changes when discharge is not balanced by the recharge. Okay. Second one, the water table is generally flat. Third, the water table is above the land surface in lakes. And D, the water table is depressed near high volume pumping wells. Option you can see on the screen, that is B, that is the water table is generally flat. This statement is false because, as I said, the water table will be flat, not like 100%, but it will be generally flat where in the plain areas. So let's say in the delta part of the Ganga River basin or some part of like that in the delta part of some of the rivers where the topography is mostly flat, there it might be possible that the water table is flat. Again, it is not applicable every time. Option C seems wrong. Okay, the water table is above the land surface in lakes. Okay, so it might be wrong, it might not be. Can anyone tell if C is wrong? How many of you says that okay, the water table is above the land surface in lakes is not correct? What it is subsurface flow. Yes, and we are talking about water table, not the groundwater. Groundwater obviously will reach again to the surface water at some point. Anyone? How many of you feel like that? Because if B is not correct, then all three should be true. How many of you like C? Someone said that is not true. I'll explain if it is true or not. Anyone else? No? Fine. Okay, I'll just give a schematic so that you can understand. What we are talking about is the water table is above the land surface in lakes. Okay. Now let's say this is the ground surface. Okay. And somewhere here is the water table. The topography can be anything like this. This is, let's say, the topography, right? Topography can be in any form. Do you guys agree with me? Okay, I'm considering that you guys are agreeing. So, yeah, topography can be in any form. Now, let's say this is the ground surface, this is the unsaturated zone, sorry, and this one is the water table, right? Now we have understood what is water table and all, so I'm not going. So, let's say this is the water table, and below which is the groundwater. Again, this groundwater will again join somewhere, and it might be possible that where some valley is there, we can have water here, and there can be formation of some lakes there. Again, after that, it might be possible that it is going down. So this is, let's say, the water table. So in some cases, it is possible that the water table is above the land surface. So where is the land surface here? This is the land surface, right? And above this is the lake. But the water table is where? Here, right? So it might be possible that water table can be above the land surface in lakes. Okay, and that's why you will see most of the lakes as flat and so on. Did I answer your question? Was that? Yeah. Dhyani, did I answer your question? If you have any doubt till now, you can ask me. I'll explain. No? Okay. Okay. This one was for the explanation of C. First one, that the water table changes when discharge is not balanced by recharge. What does that mean? Discharge as in when the water is flowing out, and recharge as in when the water is flowing inside. Okay. So we will see in many of the remediation things, you will see that groundwater recharge we're talking about, and artificial recharge also will read in the subsequent lectures. But when recharge and discharge is not balanced, then what will happen? The water table will change, obviously, right? This means, let's say if you have a bucket of water, okay, in that bucket of water you are extracting faster, whereas, so let's say you are extracting 5 meter cube per second, whereas you are only putting 2 meter cube per second. So obviously the water table that is there, it will get unbalanced, and hence the water table will change. So the first one is true, right? Third one, as I explained in this figure, it is true in some of most of the cases. And D, that is the water table is depressed near high volume pumping wells. So pumping wells as in, let's say you have some well in which you are pumping water. Okay, so because of that water, the nearby water table will get some cone of depression. We'll see that in the subsequent lectures. But what will happen? For example, let's say here only we put some well and we are extracting water, or we are pumping water from that. Okay, so what will happen? This water table that is there, it will go somewhere here. Let's say the new water is in this pumping well is somewhere here. We change color. Sorry. Oh, what. Yeah. So let's say this is the new water table after extraction. So what will happen? Something like that. So water table will so the water from other places will come to this depressions, and something like that will be, this one will be the water table while extracting from the pumping wells. So that's why the water table will be depressed near the high volume pumping wells. Okay, all this is clear. Do you guys have any question here? If not, we'll move to the next question. You guys can give me a thumbs up. No question. Okay, fine. Fine. So we'll move to the next question then. Okay. Which of the following layers in the Vadose zone is rich with organic content? I'll next I will not make, otherwise the options are coming. So we know that in Vadose zone layer, what all layers are there? First one is the soil water layer or the soil moisture layer. Second one is the intermediate layer, and the third one is the capillary fringe. In these three layers, which one do you think will have the organic content? Options are soil water, intermediate layer, or capillary fringe. Soil water layer, Surendra, Dhyani, okay. Anyone else? Soil water layer, Yogesh, okay. Anyone else? Okay, and can anyone tell why the soil water will be rich with organic content? Lina, Sumila, Kiranbala, Dheeraj. Fertilizers, okay, okay. I mean, fertilizer will increase the content in it, but yeah, naturally also if you see, the soil water layer will have more organic content because that is the place where most of the soils will be present in which nitrogen, phosphorus, and all those things will be there, and that is the place from where the plants extract their nutrients, right? Because soil contain organic matter. Yeah, yeah, you can see the topsoil contains the, yeah, plant roots from their nodules. They will extract those nutrients or the organic contents, and that's why the soil water layer will have the uh, highest organic matter among these three layers. Okay, no questions, right? I think this is clear. Okay, I'll move to the next question then. Okay, next question is what is the typical pH range of groundwater? Okay, so groundwater is mostly in alkaline form, but you'll get in some places acidic form and so on. In India also we have both the variations. Yes, acidic and alkaline both groundwater is available. So mostly, because this is an information question and answer, the answer is 6 to 8.5 mostly. Yeah, mostly 6 to 8.5. I mean, 7 to 9 is a little difficult to find all over the world. In some of the places where most of the other contaminants are being poured, you'll see that, but typical range is around 6 to 8.5. Okay, fine. We'll move to the next question then. Okay, the next question is a local water table positioned above the regional water table is said to be. Okay, this I have to explain, right? So now we will talk about some of the groundwater table part. Okay, so let's say again that part will go. Let's say this is the surface. Okay, ground surface. Okay, any questions you guys have? All right. Okay. Yeah. Yeah. So let's say this is the ground surface that we have. Okay, and let's say we have wells, two, three places. I will put Pulse aquifer. Okay, I'll come. But before that, let me explain for others once. If the answer is correct, we will come. Okay, so let's say whichever vertical column we are telling, these are wells, let's say. Okay, it can be any kind of wells. Okay, now it might be possible that the groundwater table is somewhere here. Okay, let's say I will make a column so that it will be easier to understand. Okay, so let's say this is the water table. Okay, but in some of the regions you will see that just before this continuous groundwater, there might be possible that in some of the rocks, let's say there is a big void in which the water is being stored. So let's say this is the water that is stored in this. Okay, so, and below this part, like the line that you can see, is impermeable. Impermeable meaning that no water can permeate through it. Okay, so this water table we call as, sorry, this water table we call as purged water table. Okay, so it might be possible that let's say not only here, maybe here also there is one impervious layer, but there is some voids here. So the water that is there, we call this as purged water table or purged aquifer. We will see this. The table that you can see will be the purged water table here and here. However, the whole structure we'll call as purged aquifer. We'll see. So this one is what? This one is the main water table. Okay. So the question was what? A local water table. So you see these are some local structures, right? So a local water table which are positioned above the regional water table here. Regional as in the whole region will have one main water table, right? So that water table is said to be purged water table. Okay, we are clear, right? Why it is called purged water table, right? Okay. So this mostly you will, so this layer also purged aquifer that will also be fully saturated, just to note. Okay. Fine. The next question that we have is the what is the process by which water enters the small pore spaces between particles in soils or rocks? Okay, so before this, maybe I'll start infiltration. Yeah, correct only, but maybe we'll start with the hydrological cycle and then we will see. Hydrological cycle should be here. Yeah. Okay. Yeah. So now that we know why we are studying groundwater and like what are the vertical distribution of water below the surface and so on, we'll move to the water cycle because that is where we will understand where we are getting groundwater and what are the other components the water cycle have. So just to note, like water, if you see on the earth, it circulates into three media, right? Can you tell me what all three media? If you, let's say this is, if you consider one globe or earth, there will be atmosphere, there will be the upper part of the lithosphere, and above that will be hydrosphere. For example, let's say hydrosphere as in the whole part, if you can consider. Okay, so here, where is my thing? This water cycle, you can also call it as hydrological cycle because hydrological cycle comes from the word hydrology. Hydrology is the study of all the part like distribution, circulation, and appearance of water. We call that as hydrology. So the cycle in which this water circulates, we call that as hydrological cycle or the water cycle, right? So in the water cycle, there will be circulation of water. That's why we call it a cycle, right? So there will be circulation of water. Let's say we start from somewhere. So let's say we start from the oceans. So the oceans, the water will go up. That will be evapotranspiration. So let's say I'll explain that part. So let's say oceans is there. What will happen due to the incoming solar radiation or the sun rays? What will happen? The water will start evaporating. Okay, here I am only talking about evaporation. Note that it is not evapotranspiration, it is evaporation. So water will evaporate because of the solar incoming solar radiation, because of the heat. Then these water molecules or the liquid water molecules will convert into the gaseous state, that is water vapor, and it will move to the upper atmosphere. In the upper atmosphere, what will happen? Condensation will happen. Why? Because the temperature as you move up will cool down or reduce, right? Because of that, condensation will happen in the upper atmosphere. It will form clouds, and because of wind and so on, the clouds will also move. It's not only all the clouds will move, some part of the clouds will be there near the ocean, some part of the clouds will be moving because winds are there, right? So most of the water will again fall back into the ocean, and because of this wind, the clouds will move to the land part, right? In this, again, when this water vapor, because of the temperature, it will again form into the liquid crystals, and these liquid crystals will again come back in the form of precipitation. Okay, again, can you tell me, is there any difference? Because many times we will see that we are using precipitation and we are using rainfall. So is there any difference between precipitation and rainfall? There is no difference between precipitation and rainfall. Lena, anyone else? Don't know. Okay, that's a honest answer. Okay, fine. Yes, there is. Okay, fine. So I got all the three options. It's like I am only getting question and I am only getting choose the following. Yes, no, don't know. Anyone else? Okay. So there is a slight difference because rain is the form of precipitation. Yeah, rain is the form of precipitation. So this means there is a difference between precipitation and rainfall. So the answer that you gave no is not correct. Okay, I'll come to that. Maybe I'll Add a new slide. Fine. Okay, so first thing that we were talking about, the precipitation and rainfall. So this precipitation means any form of water that are coming from the upper atmosphere to the surface of the water, we call that as precipitation. Again, I'm repeating, any form of the water that is coming from the upper atmosphere to the land surface, we call that as precipitation. Now we also know that that how many forms of water do we have? We have liquid, gaseous, that is water vapor, and solid form, that is ice, right? So precipitation, most of the form that we receive is the rainfall. So rainfall is only one form of precipitation in which the liquid form of water comes to the land surface. Okay, so other forms are snowfall will be there, right? In which solid state or solid form of water will come. So that is also one form of precipitation. Then it can be, sorry, hail can be there, drizzling can be there, okay, hailstorm can be there, right? So like this, there can be different forms of precipitation. So rainfall is just a part of the precipitation. For example, in Indian context, most of the peninsular India, central India, northeast India, these will receive rainfall in mostly all seasons and throughout the years. And that's why most of the time you will see rainfall and precipitation used interchangeably. But let's say if you go to the mountains and so on, in there will be snowfall also. So if you just say that rainfall in the mountain is considered as precipitation, that is not correct. Both snowfall and rainfall, if you add up, then it is called as precipitation. Okay. Am I clear? Okay. Okay. So the difference between precipitation and rainfall is clear, right? Fine. Then I'll move back to this. Okay. Sorry. Yeah. Okay. So where we were, we started with oceans. Now the water that is present in the oceans, that will, because of the incoming solar radiation that the heat that the land surface has present, the water will be evaporated in the form of water vapor. This water vapor will join because of the cooling effect or the transition in the temperature, where the cooling will be there because of condensation. These water vapor will again convert to liquid crystals, and when there will be like enough atoms available to make a liquid crystal, these liquid crystal will again fall back to the land surface in different forms. Different forms as in precipitation. As I said again, precipitation is like all the forms of water which are coming from the upper atmosphere to the land surface. It can be anything, any form of water. Okay. Okay. So here you see precipitation is coming. It is coming in the form of dew. It is coming as in form of fog drip. Okay, let me see anything else. So mostly it will be rainfall, snowfall, and so on. Okay, okay. This is little different. Okay. Now let's say the major things we will talk about. Now precipitation came. What will happen to that precipitation? The water came on the land surface. What all can happen to that water? Okay, we have moved from ocean to land now. Can you tell me what all can happen? Okay, I'll only tell. Okay, so the water can either flow as surface runoff, right? So water which will be flowing as runoff will, so let's say water came, it will flow on the land surface, it will infiltrate into the water, and it will also evaporate, right? Now evaporation will be only from the water or open water. So if let's say if you consider vegetation and forest and trees and so on, in that again transpiration will occur. So plants which are there in these stomata or leaves or the trunks and whatever part of the vegetation, if it is also getting evaporated, we call that as transpiration. So with total this evaporation plus transpiration, we call that as evapotranspiration. I hope I answered Safiolla's question. Okay, so evapotranspiration is the summation of both evaporation and transpiration. So in oceans, only evaporation can happen because vegetation is not there, right? So the total of evaporation and evapotranspiration we'll call it as Evapotranspiration. And most of the water resources you will see we use evapotranspiration. When we will read about models and all, we'll see that how we use evapotranspiration. Okay, so one form is done, evapotranspiration, it again went back. One is surface runoff, which will again join into the rivers and then to seas and then to the oceans, right? Because let's say if you see Ganga River also, it starts from the glaciers and then it again goes to the Bay of Bengal. Finally, it will go to the ocean, right? Surface runoff, and last is the stored water in the form of depression storage like lakes, rivers, and then stored water as in groundwater and so on. So our main focus here is the groundwater recharge or groundwater storage, mostly the groundwater part. Okay, so we understood the cycle, right? Fine. So we'll move to the, this is also the water cycle only, just in a very detailed format. Okay, here you see, let's say ocean evaporation is there, again precipitation back to ocean. Okay, because of transport of moisture from ocean to land, the clouds will move and then precipitation over land will occur at different places of the land. Okay, and then on land also evapotranspiration will occur. Why? Because their vegetation are also there. Then lakes are there. There will be domestic water use. So this water cycle is not the natural water cycle, but with human intervention in it. Because the previous water cycle that you saw, this is the natural water cycle when there is no human. Okay, now if human are there, they will use some water, they will do some things with water. Let's say industries are there here, right? Urban runoff is there, and then industrial water use there. Okay, domestic water use there, agricultural water use there, grazing water use are there. So this is the water cycle with human interventions into it. Okay, so we are mostly focused on this groundwater. Okay, fine. Any question here? If not, we'll move to the questions. Okay, fine. We'll move to the questions now. Okay, so the next question is, which of the following terms is a measure of the amount of water vapor in the air as a proportion of the maximum amount the air could hold at the same temperature? Can anyone answer this? Measure of amount of water vapor in the air. Okay, if I write it something like this, amount of water vapor in air, C, right? Evaporation rate there. Okay, let me see. And the maximum amount of air that could amount of water that the air could hold. Okay, so amount of water vapor is happening and maximum amount of the water that can happen. So whatever water is going, we are talking about that. So the correct answer will be the, okay, so the maximum the amount of water that is getting evaporated in the air by the maximum amount of the water that is the air can hold. So we are only talking about what is happening in the atmosphere, right? At the same temperature, we call that as relative humidity. So the evaporation rate is like um, how much amount of water can be evaporated in a given time. Okay, so here it is not like relative to some maximum amount of water. So whenever maximum amount of water related to that comes in the upper atmosphere, we call that as relative humidity. Fine. I hope that is clear, right? Okay, so the next question that we have is the infiltration of water into the subsurface is called D, that is recharge. Okay, anyone else? D, 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 D. Okay, yeah. The correct answer is D. Did we miss any question before? Let me check once. I think when we were doing ground to thing. Yeah, that one was not done, right? What is the process by which the water enters the small pore spaces between the particles in soils or rocks? We saw that that is infiltration, right? What is transpiration? Transpiration is the process of water moving from the vegetation to the upper atmosphere, right? Next, precipitation, we know that all forms of water which are coming from the upper atmosphere to the land surface, we call that as precipitation. And sublimation also, we know that which is happening in the land surface after we receive the water. Fine. Okay, so this is done. This we have seen relative humidity. This also we have seen that this is recharge, right? Okay, next question that we have is option is coming before. Which of the following statements is true? That is, cool air can hold more water vapor than warm water. Next is warm air can hold more water than cool air. C, cool air and warm air always hold the same amount of water vapor. And D, air cannot contain water vapor. Option is there. I mean, if you can tell me why warm water can hold more water than cool air. Anyone? I think we have only one or two questions left. I think it's B, sir. Yeah, I mean, and the option is given, but I want to know why. Because vapor are warm, okay, cool is dense. Mm-hmm. Yeah, somewhere you are going, correct. Okay, so okay, I'll give you just an example. Let's say if let's understand by some matter only. Let's say by understanding water, we will understand. You take hot water or warm water, and we'll take cool water. Okay, uh, what do you think? What will happen in both of the atoms that are present in these two condition? That is hot water or warm water and cold water. What will happen to the atoms? Because okay, first I want you guys to answer, then I'll answer. I'll repeat the question. We have two glasses of water. One in hot air, atoms will move fast. Yeah, for now we'll talk about hot water only. Okay, so let's say in hot water and cold water is there. In hot water, what will happen because of the temperature or increase in temperature, the atoms will move very fast. Okay, and they won't have that ability to combine themselves. Okay, because of this energy, because of this kinetic energy, the atoms will not collide. Whereas in cool water or the cold water, the atoms will try to condense. Okay, and because of which the all the atoms will be together kind of. Okay, so that's why the atoms which you will see in cold water will be more denser than that of hot water because of the temperature increase. Right, now coming to the air. Now in air again, you see if the air is warm, again the atoms in that air will move very fast because of this kinetic energy. The water that these voids can hold will be more, and hence you will see that warm water which warm air which is there, in that it can hold more water vapor than that of the cold air. Okay, am I clear with that? And you will see because of this climate change, we know that every year or maybe every 2 3 years, the temperature in all over the world is increasing. And we have seen that you see the IPCC reports and all. Few years back, they have said that by 2050 it will rise 1.5 degrees Celsius above the average annual. Whereas we are seeing now only the 1.5-degree rise has happened. So because of this temperature increase, the water that was available in the atmosphere before, that we have seen, right, 3% of water is available in the atmosphere. That has increased. So the water that is there below has reduced. Just to note that the water that is there in the whole earth is a constant. It cannot go outside the atmosphere. Okay. Oh, so am I clear with the this answer? The air, why warm air can hold more water than cool air? If yes, okay, 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 fine, good. I'll just take it up. Fine. So the next question that we have is the xerophytic plants can be used in the watershed management strategies. So these strategies we'll again read in maybe week 7 or something. So what are this xerophytic plant? xerophytic plants are the plants which are adaptable to survive in an environment with with little liquid water. So in less water also, some plants like let's say cactus and all can survive, right? So those are called xerophytic uh, plants. Whereas there can be some hydrophytic plants. Hydrophytic plants is like which needs more water. For example, let's say lotus, water lily, which grows in the water or maybe mud. Those are called hydrophytic plants. So here, what we are saying is that again option is coming before. The xerophytic plants can be used in watershed management strategies for. Can you give me the answer? The answer is there, but ठीक है. So let's say if there is a desert in which we can put xerophytic plants. So what will happen in desert areas? Let's say if we have some uh, people or individuals staying there or some families staying there, they need water from there, right? Okay, so the water should not like it should be for the people. So that's why we have to reduce all the aspects in which water is leaving the area or the region. Okay, so for what all aspects it can go, let's say if there is soil erosion or if there is some slope unstabilization or if there is like let's say a desert area is increasing, then what will happen? The water will keep reducing. Okay, so we have to come up with some of the adaptation strategies which we can implement to reduce this kind of water stress situation, right? So, so what we do is, let's say in the periphery of this desert area, let's say this is desert. Sorry. Okay. Mhm. 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 It's not troubling. Fine. Okay. Okay. So let's say this is the desert, and this is some maybe humid area. Okay. So now in this, what will happen? Let's say here you are putting some xerophytic plants. These are some plants I'm putting. Don't go by my diagram. Okay, so what will happen because of these xerophytic plants? What will happen? They will hold the water till there, and the desert will not move forward into the direction that it was propagating. So it will be the xerophytic plants are mostly used for reducing the encroachment of the desert areas to areas which are prone to this kind of desertification. Okay, and if there is some slopes and all in some desert areas, there also we use this kind of xerophytic plants. If you see in Japan, I have seen. Okay, and then to mitigate soil erosion. So for this, the correct answer will be all of the above. Okay, is it clear? So with this, we'll end today's session. Okay, if you have any question for today's lectures or the week one lectures, if you have not gone through week one lectures, that is also fine. You go through it, and in the next session again on Monday 6 to 8, if you have any question from the previous weeks also, I'll answer that. If you have any question in this or in the assignment questions, you can ask me in the next session. Okay. Do you have any questions right now for this week lectures? If not, we'll close the session. And even if you have anything to speak, you can tell me. Okay, thank you so much. Okay, so we'll meet again on next Monday, 6 to 8. This PPT and the recording of this also I'll upload. Maybe by today or by tomorrow I'll upload. Okay. Okay, so if there is nothing, yeah, thank you so much, Surendra. Thank you so much, Dhyani, Dheeraj, everyone. Okay. Okay, I'll. Okay. Thank you, Dayanand. Thank you so much. Okay, so I will stop this presentation. Okay, first I'll stop recording. Thank you so much. You guys can.